Good afternoon, all you studious learners. We are continuing in Chapter 3 for geometry, and we've been talking all about what happens with angle pairs when we have a transversal intersect two lines. Well, now we're going to kind of go in the opposite direction. So before we were told, yes, these lines are parallel. Now say something about the angles. In this unit, we're going to be told something about the angles in order to prove that the lines are parallel. So it's just kind of in reverse. So you've already been introduced to the original theorem that I have up here, or theorems, and we are going to talk about the converse. So today I'd like for you to be able to prove that two lines are parallel by using the appropriate postulates or theorems. The first thing I want to remind you of is what a converse is. So in our last chapter, chapter 2, we talked about converse, inverse, and contrapositive. But the converse is what we're going to be focusing on today. And converse is backwards. In other words, you switch the hypothesis and conclusion. So we're going to do that in these examples real fast. And it says, if two lines are parallel, then corresponding angles are congruent. Well, now we're going to make that go backwards, and we're going to go ahead and assume that we have two parallel lines and a transversal cutting them, because it becomes a little redundant, and I just don't want to take a super long time to write all of those things out for you guys. But in all of these, we are going to assume, yes, we have two lines and a transversal across them. So we're going to flip this around, and it's going to be if corresponding angles are congruent, then the two lines are parallel. So if corresponding angles are congruent, then the two lines are parallel. And as you can see, I'm using my shorthand to kind of speed this up a little bit, and you are allowed to do that too, because I know that writing the same words over and over do get a little annoying after a while. Next, we have alternate interior angle theorem. Now, that states if two lines are parallel, then alternate interior angles are congruent. We're making that go backwards once again. So this time, if alternate interior angles are congruent, then the two lines are parallel. We're going to do this same type of pattern for the next one as well. That is the alternate exterior angles theorem. And it says if two lines are parallel, then alternate exterior angles are congruent. I'm going to go ahead and draw a picture of that just so you can see it. So let's say that we have two parallel lines right here, and then they're cut by some transversal. Sorry, I bumped my camera. Like this. Alternate exterior angles. An example would be these two guys. Okay, if these are congruent, then the lines are going to be parallel. That's our converse. So if alternate exterior angles are congruent, then the two lines are parallel. So notice how we have three angle relationships that are congruent. Our fourth angle relationship that I'm going to talk about on this page of the notes is going to be same side interior angles. These are not congruent, but they are supplementary. So that's the one angle pair that's kind of different from the rest of them in that sense of the word. So same side interior angles. If two lines are parallel, then same side interior angles are supplementary. I'll draw those for you just so you can see it as well. Let's say that we have two pairs of parallel lines cut by a transversal. This guy and this guy would be same side interior angles. So we're going to flip this around. If same side interior angles are supplementary, then the two lines are parallel. So these are their own theorems, these converses, but they're very closely related, so hopefully it doesn't feel entirely like learning four new things. Hopefully it just feels very familiar to you, especially since we covered super similar stuff in yesterday's notes. Let's start applying this and putting it into action. So example 1 says, use the converse of the corresponding angles postulate and the given information to show that L is parallel to M. This should say theorem. So in this example A, it says 4 is congruent to 8. So 4 is congruent to 8. I'm going to say, oh, those are corresponding angles. So I'm going to say corresponding angles are congruent. 4 and 8, one more time, I'll go ahead and label them right here and right here. Because it has the congruency symbol, I know that they're the same measure. If 4 and 8 are congruent, then I know that L and M are, or the lines L and M are parallel to each other. So corresponding angles are congruent, therefore line L is parallel to line M. So that one was kind of easy. It gave it to us right then and there. For problem B, it says the measure of angle 3 is 4x minus 80, and the measure of angle 7 is 3x minus 50, and x is equal to 30. So here I have angle 7 and angle 3 marked in orange for you. And what I'm going to have to do first is substitute. So I need to figure out what these actual measures are given that x is equal to 30. So my step 1 is substitution. So for the measure of angle 3, that is going to equal 4 times 30 minus 80, and that's going to get me 40 degrees. Now let's do the measure of angle 7. It's going to be 3 times 30 minus 50. 3 times 30 is 90. 90 minus 50 is 40 degrees. Okay, so that means they have the same measure. Therefore, they are congruent. So then my step 2, because these are corresponding angles, they are the same measure, so they are, and that means they're congruent. I now know that these two lines are parallel. So because corresponding angles are congruent, line L is parallel to line M. And I'm done with that one. So notice before we were told that lines are parallel and we wanted to find something out about the angles. Now we're finding out something about the line or the lines, which is essentially if they are or are not parallel to each other. Let's look at example 2. It says, use the given information and the theorems you have learned to show that R is parallel to S. So now we're told that angle 4 is congruent to angle 8. So 8 right here, 4 right here. What type of angles are these? They are alternate exterior angles. So I'm going to say they are alternate exterior angles. But not only that, they are congruent to each other. Now, based off of this front page in our converse of the alternate exterior angles theorem, right here, it says if alternate exterior angles are congruent, then the two lines are parallel. So that means in this example, in example 2, part A, because 8 and 4 are alternate exterior angles, they're on opposite sides of the transversal and on the outsides, and they're the same measure or congruent to each other, the lines must be parallel. So thus, line R is parallel to line S. In example B, this is very similar to our example B up above. We have the measure of angle 2 is equal to 10x plus 8, and the measure of angle 3 is equal to 25x minus 3, and x equals 5. We need to figure out, first of all, what those actual angle measures are. So we're going to substitute first. So substitution. And I'm going to say the measure of angle 2 is going to equal 10 times 5 plus 8, which is going to get me 58. Measure of angle 3 is going to equal 25 times 5 minus 3. Well, 25 times 5 is 125. 125 minus 3 is going to be 122. These are not the same measure. These add up to 180 degrees. They are supplementary. Let's also locate where 2 and 3 are in our image. Here's 2 and here's 3 in orange. Well, they're same side interior angles. Notice how 2 and 3 are both on top of the transversal, and they're on the inside or in between the two parallel lines. So they're same side interior angles, they're supplementary, and same side interior. Therefore, line R is parallel to line S. That is based off of the converse of the same side interior angles postulate, because it says if same side interior angles are supplementary, then the two lines are parallel. So we're kind of breezing through this because those haven't required too many steps. Let's look at our last example and then we're done with today's notes. Example 3 says a carpenter is creating a woodwork pattern and wants two long pieces to be parallel. Measure of angle 1 is equal to 8x plus 20, and the measure of angle 2 is equal to 2x plus 10. If x equals 15, show that pieces A and B are parallel. So these are my two pieces, A and B, and I want these guys to be parallel to one another. I also know the value of angle 1 is 8x plus 20, and the value of angle 2 is 2x plus 10. These are my parallel lines, and this right here going horizontal is the transversal, which means that this guy and this guy need to add up to 180 degrees in order for these boards to be congruent, or parallel to each other. So let's substitute in 15 for x and see what we get. So we got measure of angle 1 is equal to 8 times 15 plus 20. Measure of angle 2 is equal to 2 times 15 plus 10. 8 times 15 plus 20 is going to equal 140 degrees. So 8 times 15 is 120. 120 plus 20 is 140. 2 times 15 plus 10 is going to be 40 degrees. Now notice that 140 and 40 are supplementary. So step 1 was substitution. Step 2, measure of angle 1 and measure of angle 2 are supplementary. Three. So now, because same side interior angles are supplementary, we know that piece A is parallel to piece B. If 1 and 2 added up to anything differently other than 180, then we would have to say that A and B are not parallel. But because they added up perfectly to 180, right, 140 plus 40 gets me that number, then I can confidently say that these two lines are in fact parallel to each other. That's all for today's notes. I hope you have a good night, and I'll see you later.